Hello students, welcome to all of you to class 11. Right, generally we do the welcome in classrooms, but this time it is through phone. It's okay. And we will start here with the very first chapter, sets. It is very simple. It's just like playing with numbers as you people have done in the junior classes also. The few things will change definitely, but you will find the chapter easy as well as interesting, right? I will start with one or two simple examples when I'm talking about sets, right? All of you know when I write down this n, what does it mean? When I write down r, when I write down z. Okay, what is n? When we say n, capital N, we say it is the set of natural numbers, right? We use these words. Capital R means the set of all real numbers, and Z we say it is the set of integers, means both the positive and negative. Here when I am using natural numbers, that means it will start with 1, 2, 3 up to so on. Real numbers, all the negatives will be there, all the positives will be there, rationals, fractions, irrationals, integers, zero, everything will be there. And when I say z, set of integers, it will be minus infinity to plus infinity, or I will say minus 4, 6, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on, right? But my thing here, I'm not talking about the numbers. My objective here to consider these three examples to bring the focus on this word set. We have used this word set in junior classes or earlier as well. Now what is this set? When I'm writing n, everybody knows it will start with 1. When I write n, I cannot start that it will be 0, 1, 2, 3 and so on, right? Because 0 is not a natural number. The natural numbers are starting from here, 1, 2, 3. So when I say n and I explain n with the counting 1, 2, 3 including 0, it is no longer a set of natural numbers, because this number is making a problem to the definition of natural numbers, right? So what I will say here, this collection is not well defined, but once I remove this 0 and I start 1, 2, 3, 4, 5, 6 up to so on, there is no end. Now when I look at these numbers, everyone will immediately say this is the set of natural numbers. So what is the set? Set is well defined collection of objects. Well defined collection of objects, right? So when I look at 1, 2, 3, 4 so on, this is well defined. What is well defined? All these are the natural numbers, and the collection of all the natural numbers, we have used capital N to represent this collection, and it is the set of natural numbers, right? Let me take one more example. A, E, I, O, U. All these are English alphabets, but one special feature is there. All these 5 English alphabets are known as vowels, right? Now each and every letter or alphabet which I have written here, every letter is a vowel, nothing else. So what I will say, this is the collection of vowels, है ना? This is the collection of English vowels, not any other language, but this is the collection of English vowels. And when I have a well defined, is it well defined? A is English vowel, E, I, O, U. Each and every letter is the English vowel. So it is well defined collection of English vowels, and then this will again represent a set. So in other words, what is set? Simple, it is the collection. What kind of collection? It is well defined collection of objects, right? Let me take one more example. The rivers of India. The rivers of India. When I write down the names of the rivers of India, Ganga, Yamuna, Saraswati, Beas and others, so many are there. When I list them, right, And when I look at each and every name of the river, each and every river will belong to only one country. What is that? India. So each and every object or each and every name of the river will represent the same country. So that collection also will be a well defined collection. And when I say it is well defined collection of objects, it means that is making a set, right? If I take one more example, I am writing all the prime numbers till 100. Now, you know very well what are the prime numbers, the numbers which are divisible by itself. Na? So, what are the prime numbers? You can list them, and till 100, whatever prime numbers you are getting, and when you look at each and every prime number, it is following the same property. So, yes, if I write down the prime numbers till 100, that is again a well defined collection. If it is well defined collection, it is making a set, right? So this is how the concept of sets comes. So in the book it is mentioned that the theory of sets was developed by German mathematician Georg Cantor, right? It is very important concept of mathematics. It is used widely in so many branches of mathematics, right? Set theory is a major concept, and we are just having the introduction of this topic in our syllabus, right? So let me tell you one thing now. I have explained you the set. What is the set? It is the well defined collection of objects. So whatever I can take, the objects can be the English vowels, objects can be the numbers, objects can be the names of river, objects can be anything. The only condition is it should be well defined. There should not be mixing of different types of objects. Whenever you take the collection will be should be based on one single criteria, right? So that will make that collection will be called the set. So this is the definition of the set. You people are supposed to write down the definition, the examples that we have considered here, all the things you will be writing in your register, right? Now there are few methods also when we look at the set. For example, let me take this example. Well, we have written the English vowels. When I am writing the English vowels A, E, I, O and U, right? And I have to write down this thing in the form of a set. How will we write down? These vowels we will separate by the commas, and we will write down within the curly braces. No other bracket will be used. We will write down them in the curly braces, and whenever we have to give the name to the set, we always use the capital letter. The set will be represented by capital letter, but the objects or the elements that we are writing will be written as the small letters. So A, E, I, U, actually these are English vowels, but when I am writing them in the set separated by commas within the curly braces, this is the way to represent, and the set is written by, or the name will be given by capital letter only. So let us say this is A, and these A, E, I, O, U will be called elements of the set. These are elements of a set. And what is the name of this set? It is A set. And this is one way to write down. Okay. So I hope it is clear how to write down the set. All the elements separated by commas within curly braces. Always the bracket should be only curly bracket, no other bracket, no square bracket, no simple parenthesis, nothing. And the name of the set will always be given by the capital letter, right? Now the next thing that is here, how to represent the set. There are two ways to represent the set. We will write down here representation of set. There are two ways. The first is roster method or roster form method you can use, or form word you can use, a roster form. And the second one is set builder form, right? These are the two ways to represent the set. Roster form means if I say A is the set I'm writing all the elements of the set. For example, let me take the same A, E, I, O and U. What is this? This is the collection of all the English vowels. All the English vowels, when I write down, when I list every element separated by commas within curly braces, it is called roster form, right? So if you want, you can write down the definition also. So roster form means all the elements of the set are listed within curly braces separated by commas. So this is the method, or this is the first form of representation of the set, that is roster form, when you are listing each and every element. And this roster form is also called tabular form because you are listing everything, right? So this is also called tabular form or the roster form. Most of the time we use this word only, roster form. So all the elements separated by commas within curly braces. Now the next method is set builder form. If the same set I write down here A, instead of listing the elements, I write down the property. What is the property of this set when I look at each and every element? A is a vowel, E is a vowel, I is a vowel, O also vowel, U also vowel, and these are the vowels of which language? English. So what I will write down? A, I am writing here all X, where X is a English vowel. Every X, how we are writing? We are writing the formula. Either you say it is the formula, or it is the criteria, it is the property possessed by each and every element of the set. So all X, how will we read it at? All X such that X is a English vowel. When I read this thing, all X such that X is a English vowel, so automatically all the English vowels will come to my mind. So this X can be A, it can be E, I, O or U. So all those elements are here. So the same set, this is the roster form, same set we are writing in the set builder form. Let me take one more example. When I write down B set such that all X I want, such that X belongs, okay, X is a natural number and X is less than 10. Okay, I am writing one property. What is the property? I am writing in this set B is having all X such that X is a natural number and it is less than 10. So when I list all the natural numbers which are less than 10, the first natural number 1, then 2, then 3, 4, 5, 6, 7, 8 and 9. Because we want all the natural numbers less than 10, so 10 cannot be included. That's it. So when I list them, it is the roster form. When I write down the property of the elements, then it is the set builder form. So the same set but in the two different forms. Clear? So this is all about the representation of the set, roster form and set builder form. Right? So it is, if this thing is clear, we will move to the next part. Now the next thing, when I am writing the same, let us take the same example, B set I am writing here. The B set is having the elements 1, 2, 3, 4 up to 9. Now 1 is the element, 2 is the element of which set? B set. 5 is the element of which set? B set. 7 is also the element of which set? B. So there is one symbol. This is epsilon actually. The symbol's name is, if you pronounce it as epsilon else also, epsilon also, it's your wish, the way you want to pronounce, perfectly okay. And this symbol means belongs to. In mathematics it means belongs to. It's an epsilon, the name of this symbol, right? And the meaning is belongs to. How we are writing it? C and then line in between. It's not E. Take care. We will not write it as E. That will be wrong. You have to write down C and then the line. The meaning of this symbol is belongs to. And this symbol we use to make the relationship between the elements and the set. How will we do it? Let me show you. 1 and B. What is the relationship between 1 and B? Does 1 belong to B set? Yes, 1 is there in the B set. So we will write down 1 belongs to B. Right? Now 7 and B. What is the relationship between 7 and B? Does it belong to B? Yes, it belongs to B. So it will go like this. Now 10 and B. Do we have 10 here in the set? No, there is no 10. So when there is no element present in that set, we will simply cross that symbol of epsilon and it will be read as 10 does not belong to B. 1 belongs to B, 7 belongs to B, but 10 does not belong to B. Remember, the symbol will be used between the element and the set only. It cannot be used between two sets. Take care. This symbol is used to represent the relation between, it is used to show relation between set and element. Okay, not between two sets, not between two elements. Take care of this thing. So your first exercise actually is having all these things. The first sum is which of the following are sets? Justify your answer. And then second sum, we have to use the appropriate symbol belongs or doesn't belong. Sum number 3 is there to represent the set in the roster form, right? We will discuss one part from few sums so that you can complete the exercise, right? Okay, class.